Okay, we're continuing our example of solving a compound linear inequality. We had just finished clearing the compound linear inequality of fractions, just like we would any equation or inequality, clearing it. And now we're going to go ahead and we're going to work on getting the x isolated in the middle. Remember that the x must remain in the middle. You may not reduce a compound inequality into a single simple linear inequality ever. Okay, now I've added 4 to this middle, and so I must do the same thing over here on the left and over here on the right. Remember that a compound linear inequality is always 3 parts. 8 plus 4, which is 12, less than or equal to 3x, less than or equal to 9 plus 4, which is 13. And then finally, we want to remove the numeric coefficients, so multiplying by the reciprocal in the middle to do that. What I do to the left, I must do both to the middle, I must do both to the left and to the right. And now 12 divided by 3, which is going to give me a 4, and then less than or equal to, and then x, and less than or equal to, and 3 will go into 13 4 times with 1 left over, so this is 4 1/3. So now I'll go ahead and I'll graph this on the number line. So I'm going to go ahead and I'm going to locate my left endpoint, and I'm going to put a bracket on it, or left bracket, because that is the left side, it is included. And then I'll go locate my right endpoint, which is 13 thirds. 13 thirds right there, and I'll put a bracket on it, and then I'll put a line between those. And now interval notation, 4 is my left, it is included, so it's got a bracket, up to 13, and those are thirds, and that one is included as well, so it's got a bracket on it as well. And so there's my solution set, and those are all the parts. All right, moving along to example number 46. Example number 46, one of the things that you should notice here is that we have a big number here and a small number here. Don't let that concern you when it comes to compound linear inequalities. Don't ever make any snap judgments until these things are solved of whether this is going to have a solution or not. So 7 is less than or equal to, and I distributed out the negative there, minus x, and minus 5 is less than or equal to 2. Now I haven't multiplied or divided by any negatives throughout this thing, so nothing happened with the reversal there. Don't get caught up in that. And now I'm going to move the negative 5, so I'm going to add 5 to all 3 parts of it, both to the left and to the right sides of this inequality. And now I have 12 is less than or equal to a negative x, and then is less than or equal to a 7, and then finally I need to get rid of that negative numeric coefficient. Well, this means I'm dividing by or multiplying by the reciprocal of a negative number. That, remember, is what flips our inequalities here. And so what we have going on here is a reversal of the inequalities, and 12 divided by a negative 1, which is going to give us a negative 12, and then an x, and then a negative 7, and then we are going to have to move this around, the negative 7 over on this side, the negative 12 over on this side, the x in the middle, the less than or equal to here, and the less than or equal to here, and then we can read it and we see bigger number, smaller number, and so yes, this is going to be a null set. Unfortunately, that's not the way that I meant it to come out. I meant it actually to be a correct inequality, and I think I must have written it incorrectly, and so I apologize. That was my my mistake there. So we should see, though, that the reversal happened, and that was the most important thing, that I wanted you to be able to see this reversal of the inequality and having that give us the solution set and flipping the inequalities. This still happens even with the compound inequality. So I'll continue on in the next video. I'll make up one example, and then we'll do Lehman's word problem example as well in that next video.